Good morning, students. I am N. Rajalakshmi, lecturer in Computer Science Department, working in YA Government College of Women, Chirala, Babatla district. So, in this video lecture, I explain linked list. By the end of the session, you are going to learn what is the linked list, why linked list, and what are the advantages and disadvantages of the linked list. Linked list is the linear data structure. You know the different types of data structures, linear and non-linear data structures. So list, array, stack, queues are the linear data structures. Trees and graph are the non-linear data structures. Array data structure is the linear data structure. Then what is the need of another linear data structure, linked list? What are the drawbacks of the array data structure? There are some drawbacks for the array data structure. To overcome the drawbacks of the array data structure, we need one data structure, that is the linked list. So linked list is the linear data structure. Okay. So what is the need of linked list? Why the linked list means array data structure has some drawbacks. To overcome that, another data structure is needed. So that is the linked list. Okay. The drawbacks of the array data structure are overcome by the linked list data structure. So what is the linked list? Okay, look at here. This is the representation for the array data structure, and this is the representation for the linked list data structure. You know, in the array, all the elements are stored in contiguous memory locations, means side by side. That is, and if you know the address of one element in the array, then you can easily calculate the addresses of all other remaining elements. That is, suppose the address of this element 10 is 1001, then address of the next element definitely it is 1003. Okay, so these are all integer elements, so the difference should be 2 into data type, and the address of the next should be 1005. Okay, like that you can easily calculate. All the elements are stored in contiguous memory locations. But in case of linked list, the elements are stored in non-contiguous memory locations. These are not side by side. Okay, this is the memory location for the first element. This is the memory location of the second element, third element, fourth element. Here the location is divided into the two parts. Here only one part. Here the location is divided into the two parts. Here 4 elements, 4 locations in the array data structure. This is the representation. In the list data structure also 4 elements. 4 elements. Okay, here I represented 4 elements, 4 locations. For each element, one location. Okay, 4 elements, 4 locations. Here, in case of arrays, the location is not divided, single block. Okay, 4 blocks, all are side by side, contiguous memory locations. Okay, a large memory block. Okay, here the memory location of each element is separate. Okay, these are non-contiguous memory locations. Okay, and also each location, memory location of each element is divided into the two parts. Why two parts? Here, in case of linked list, elements are stored in non-contiguous memory locations, so it is not possible to identify the addresses of all other elements, even though we know the address of the first element. But in case of arrays, if you know the address of the first element, or not only first, if you know the address of any element in the array, then you can easily calculate the addresses of all other remaining elements. But in case of list, it is not possible. That's why addresses of the elements should be held by the elements. Okay. So to hold the address of the next, the location is divided into the two parts. First part holds the data. Second part holds the address of the next. That is, in case of arrays, no need of holding the addresses of the next element. But in case of list, there is a need to hold the address of the next elements in the list. That's why the elements in the linked list are linked with the next element. That's why it is called linked list. The elements in the list are linked through the pointers to the next element. Okay, this is the link. What is this link? This is the link between the first element and second element. So first memory location, it contains the two parts, two values. One is the value data part. Second one is the address of the next. Where is the next element? Where we have to go to search the next element, address of the next. So, and here data part and address of the third element is stored here, like that. Okay, and the last one, this is the last one. There is no the next element, so here the address part is null. Okay, that is address part of the last element, last node. In the last node, the address part is null. Here the each block, each location, each one is called as the node. Okay, here it is the locations, memory locations. Here it is the node memory. Here also it is the memory location, but it is called as node. Node consists of two parts. One is the data part, another one is the address part. Address of the first element, first node. This is the node 1, this is node 2, this is node 3, and this is node 4. So node 1 holds the address of the node 2, node 2 holds the address of node 3, node 3 holds the address of node 4. In the node 4, there is no node 5, so address part is null. Null indicates it is the last one. Okay, so look at this here. Here the element is A, here the element is B, here the element is C, here the element is D. So this is the first node, head node. Okay, so in this part, address of the element B should be written. In this part, address of the element C should be written. In this part, address of the element D should be written. Here, this is the last one, there is no next, so address here null. Okay, so that is, array is the collection of similar elements. Linked list is also the collection of similar nodes. Linked list is the collection of nodes. Each node is linked to the next node. Okay. Why the linked list? What are the advantages of the linked list and what are the disadvantages of the linked list? So first come to the advantages. So linked list has some advantages over the arrays. The first one is the dynamic size. Second one is the insertion and deletion operations are easy in linked list, but more difficult, expensive in case of arrays. Okay, let us see the first one, dynamic size. List is the dynamic data structure. Linked list is the dynamic data structure. It is dynamic in size. Size means array is the static in size. Here size means it is the number of elements. In the data structure array. or in the data structure list. Okay, here, so this is the array data structure, this is the linked list data structure. Here how many elements are there? 4. So size is 4. Size of the array data structure is 4. And here also size of the linked list data structure is 4. Okay. So array data structure is the static in size. That means the size of the array should be declared at the beginning. Before the compilation, before the execution of the program, the size of the array should be declared, should be defined. And it should not be increased or decreased. It is fixed. So that's why it is static. Okay. Suppose the size of the array data structure is defined as 100. Then if we read the below the 100 elements, in such a case, a lot of memory may be wasted. If you read the above the 100 elements, in such a case, more memory, additional memory is required. Okay, that is the drawback of arrays. The size of the data structure is static. Okay, it should be defined and declared before the compilation and execution of the program. But in case of list, size of the data structure, that is how many elements we read, that is not specified before. That is specified at the runtime. So here the memory is allocated at the compilation time. Here the memory is allocated at the runtime. So at the time of reading the element, the memory is allocated. In case of list, when we type the element 10, then the memory is allocated for the element 10. When we type the element 20, then only it allocates the memory for the element 20. That is, here the memory is allocated for the individual elements. Individual elements, not grouped. But in case of arrays, the memory is allocated for the group of elements at a time. Here the memory is allocated for individual elements. Why? Because that's why memory allocation is individual. That's why the elements are stored in non-contiguous memory locations. So to group the elements as a list, each element is linked to the next element in the list through the pointers. That's why here the node is location is divided into the two parts, data part and address part. So this is called as the node. Node is the collection of two parts, data part and address part. Okay. So array is the static in size, list is the dynamic in size. Now, in case of list, we no need to specify the number of elements. We can insert, we can read any number of elements. It is unlimited in size, but array is limited in size. If we specify the size 100, it is limited to 100 elements only. But in case of list, we are not specifying the size. Any number of elements we read into the data structure. So list is the dynamic. Okay. At the time of reading the element, the memory is allocated. So it is dynamic. Here the memory is allocated at the beginning. It is fixed. So it is static. Okay. Second advantage of the linked list is ease of insertion and deletion operations. Easier. Insertion operation is easier in case of list. But in case of arrays, it is more expensive. So let us see how the insertion operation is expensive in case of arrays. So this is the array data structure. So in this data structure, I may insert the element, I may want to insert the element between 12 and 15, like this. I may want to insert the element at the end, I may want to insert the element at the front. So in this case, between 12 and 55, to insert the element after the 12 before the 55, we need to shift the elements from 55 to the last element 66 to one position to the right. So shifting of the elements is needed here. And in case of the insertion at the beginning, at the front, here also we need to shift all the elements from the first to the last to one position right. So shifting the elements to the right or to the left is expensive. It takes some time. That's why insertion operation is expensive in case of arrays. But in case of list, shifting is not required. You can insert the element at any point, at any position, just by removing the link and attaching the link to the required element. Okay, that you will understand in the next session on insertion and deletion operations on the linked list. Next, what are the disadvantages of the linked list? Linked list has also some disadvantages. And the first one is the random access is not allowed in case of list, but in case of arrays, random access is allowed. So in case of arrays, all the elements are stored in contiguous memory locations. So you can access any element from the array using its index. Here the elements are indexed starting from 0. Okay, but in case of list, there is no such type of index. So random access is allowed in case of arrays, but in case of list, there is no random access. Why? Because array elements are indexed starting from 0. So using the index, you can easily access any element. But in case of list, there is no index, so it is not possible. And the second one, extra memory space is required. Why it requires extra memory space? Here, in case of arrays, to hold the 4 elements, how much memory is required? For each element, it requires 2 bytes. For 4 elements, 8 bytes. But in case of list, how much memory it requires? For 4 elements, 8 bytes plus each element holds the address of the next element. So here, to hold the address of the next, another 2 bytes is needed. Here another 2 bytes, here another 2 bytes, here another 2 bytes. Totally, here 4 bytes for the element, 2 bytes for the address 2 bytes. And here also for the element 2 bytes, for the address 2 bytes, like that. To hold the 4 elements using the linked list data structure, 16 bytes memory is required. But in case of arrays, it requires only 8 bytes. So that is another drawback. And it is not cache friendly. Cache friendly means so array elements are contiguous. So there is the locality of reference. That is not in case of linked list. List elements are non-contiguous. So these are the advantages and disadvantages. I hope you understood what is the linked list data structure and what are the differences, comparison between the array data structure and linked list data structure. What are the advantages of the arrays, disadvantages of the arrays, and also same what are the advantages of the linked list and disadvantages of the linked list. Good. Thank you very much.